Right, so many of you guys were taking photos today, be it at the booths, from outside. Some of you even bumped into old friends. Here, I heard a few of you guys, hey, it's so long never see you already. How have you been? Right, and because of that, you guys took photos together. Now, our friends with muscular dystrophy, however, might not always be able to take photos themselves. Depending on the severity of their condition, holding up a phone to take a snapshot, a selfie, or even a Wi-Fi might not be as simple as it sounds. How might we then use tech to craft a solution that is hands-free, portable, and easy to use that will allow our friends with muscular dystrophy to exercise independence and the full creativity of their work? And the first team to come on board to tackle this issue is Team SST. Let's welcome them with a big, big, big round of applause. Team SST, let's go.
Good afternoon, everyone. Here is Team SST. So this is eye level, and this project was made by Team SST for this festival. There are over 300,000 people in the world who are currently living with muscular dystrophy, and that's a large number. And how are we going to solve it? We are from SST, and I'm Srinidhi, that's Jaden, and Leong. So the main point is that our innovation isn't really a product, it's rather a service. Why is that? It's because muscular dystrophy is on a spectrum. So there's different types of muscular dystrophy, there's also different types of wheelchairs for each of them. And thus, there isn't like a one-size-fits-all solution for each need. And thus, we're creating a custom solution for each person experiencing muscular dystrophy. So how could we help? We need to find a way to let them take their own photos and videos with their own perspectives independently and creatively without the need of a helper. And thus, the solution is a mechanical arm. Here's Jaden to talk more about it.
So the mechanical arm is a pen-tailed model, easily with easy controls. The mechanical arm is also made out of Legos. So there is a light sensor strip which controls two servo motors respectively to move the camera, focus, and perspective. It's much easier to activate and use compared to joystick as it does not involve a lot of muscle movement. And it provides a much easier and pleasant experience for users. So we also have a lock system which allows the mechanical arm to stay in the camera mode for usage and a lock mode for when the user needs to get off the wheelchair. The mate can activate the lock mode which moves the cameras out of the way. So now Leong will talk about the challenges.
Click the back button.
So the main frame that we use for the materials is the Lego. However, what we found out was that Lego is quite flimsy. So what we end up planning on doing is we want to use stronger, lighter carbon fiber. This is a bit more expensive, which is why we didn't use it for the prototype, as we need more, as our budget wasn't high enough. However, if we plan to make it into a commercial product, we will need it to be more sturdy, and thus we will have to use the carbon fiber. Another problem was that the Raspberry Pis were really eating a hole in our budget. Hopefully in the future, there can be better, high quality, mass-produced chips that we can use so that we can better make our product, yeah. So I also want to talk about one of our main inspirations, David Han Solo. At the age of 9, he began researching on how to build his own prosthetic arm. And 9 years later, at the age of 18, he finally completed his own prosthetic arm. Over the years, he has made many prosthetic arms, and his innovation and drive or passion to helping others really inspired us. So yeah, now to Sri to recap the last 3 months.
So for the last 3 months, at first we were like building the mechanical arm. And for the mechanical arm, we used Lego, since it was much cheaper and also a prototype that could easily be built. And then we used optimization. We tried to underclock the Raspberry Pi, and we were successful with it. Because like we need to let the product last longer because it's going to be powered by the power bank. So we have to underclock it so that it uses less power, and thus it will last longer throughout the day, letting them use it for the entire day without needing to charge it. And then we're working on the camera script, where if they click the light sensor, they just have to tap it once, and it will automatically take the photo and also upload it to Google Drive so they can access it easily at home. And also a pen-tip module code, where they have to tap and hold the light sensor. And what that does is that it changes the position of the servo motors that are connected to the pen-tip module so they can pan and tilt the camera to their own needs. And then we finished and played with the cat, which is at the makerspace. And to read up more on muscular dystrophy, you can scan these QR codes. The first one is for Wikipedia about muscular dystrophy, and the other is the CDC website for it. Thank you for listening.
Thank you, Team SST. Thank you very much. All right, wait, I have just one quick question. Oh, alamak, you're leaving behind. It's okay, it's okay. No, just one quick question for either one of you. I think the audience just want to hear, even those at home and FB Live, right, Facebook Live, will want to figure out and find out more about your journey in the past few months doing Tech for Good. What is one of the biggest challenges that you experienced in your few months journey with Tech for Good?
Well, I would say the biggest challenge is that at first we were trying to use a button, but then we talked with Timothy, who was our community partner, and then we realized that the buttons was actually like really hard for them to control. We also used the joystick, but it was also really hard. So we swapped to a light sensor, and the main problem is that we wanted to use a touch sensor, but that was out of the budget. So the light sensor has a problem where if you are in a dark environment, it starts taking the photos. So that's the main problem that we are trying to overcome.
Got you. Thank you so much. So it is about finding solutions that meet the budget while kind of addressing the issue itself. Yeah. Great. Thank you so much, Team SST. Well done.
Thank you.
All right, thank you. Next in line, we have a team from Yuhua Secondary School. I hope I pronounced that correctly, Yuhua. Not very good with Chinese names. This team will be talking a little bit more about independent creative photography for the people that they're going to serve. So, can I bring in the team from Care 3? Can I give them a big round of applause, please? Thank you very much.
Hello? Okay, this works. Okay. Good afternoon, everybody. I am Chen Xiu from Team Care 3, and today I'm here to present to you about our solution, independent creative photography. But let me introduce the team first. So you have me, you have Sen Yuan, we have Sen Yuan, who is helping me demonstrate, and we have Arden and Lavanya, who is at the booth over there. And we also have two mentors, Mr. Stanley and Miss Yvonne, and then our community partner, Mr. Boon Kang, who, as far as I'm seeing, he couldn't make it today, but that's okay. Okay, next slide. This what? One. Is it working? Working. No, right?
This one. No. This one.
This one?
Yes.
Oh, sorry. So, this is our solution. We call it a helping hand. And it consists of the extension arm, the keyboard control, the pen and tilt mechanism, and the wooden holder to hold the extension arm. And this is how it looks like when it's assembled together here. Yeah, wait, let me just... There you go. This is how it looks like. So how does this answer the problem statement? With this device, people with muscular dystrophy can use their phones to take a photo, and it allows the user to use the pen and tilt mechanism to take the photo, which eliminates the frustration of having to rely on their helper to take the photo because the helper might get it wrong. And like this, the user can do it himself instead of having to rely on the helper. So when we were coming up with ideas, we took the following design considerations. The product must be easy to use. The product must be comfortable to use. The user should move as little as possible. The product must be easy to assemble. The product must be adaptable to all brands of phones. The product must be cheap. There should be no proprietary parts. There must be standard parts. The product must be rust resistant. The product must be easy to maintain. And the parts must be easily found and replaced. So why should you all vote for our product? Well, it's easy to use, it's easy to put together, it's adjustable, and it can be mounted on other things also, like tripods. It's possible to rotate and choose the degree that you want to take a selfie as well as take a picture of the surrounding environment. And it's not expensive to purchase. Okay. How do you play the video? Yeah, and this is the video of the demonstration of how to assemble our product.
First, insert the shorter
also added
extension rod
subtitles.
into the extension arm at the top. Then insert the longer extension rod into the extension arm at the bottom. Next, clip the wooden holder to the wheelchair as shown. Then, clip the extension arm to the wooden holder. After that, screw the cylinder containing the pen and tube mechanism to the extension rod above. Connect the pen and tube mechanism to the keyboard control using a computer cable as shown. And finally, place the phone on the phone holder.
Okay, and now there'll be a demonstration of how to use the product on the screen as well.
Press
We'll
the
also
left
be
button
doing a
to
live
move the phone
demonstration
left.
of how to use it as well.
Press the right button to move the phone right.
Our product is, how to say, it might be a little bit faulty, but in the case that it is, you can just watch the video. Sorry.
Press the down button to tilt the phone down. Press the top right button to take a photo.
Okay, that's the user manual. So, in summary, our product consists of an arm and keys to control it. It allows people with muscular dystrophy to control their phone and take photos without help. And it is inexpensive, easily obtainable, and comfortable, and easy to use. Okay, that's it. Thank you, everybody.
Thank you, Team Care 3. Good. Oh, later when you pass, can pass back over there. Don't worry. Yeah. So later when they go over to your booth, right, can they play along with the little box that you have over here?
Yes, we have a second prototype that works as well, and it's at our booth, so they can use that instead lah.
So you have multiple prototypes for more people to come and play rather than just one person lah.
Yeah.
Fantastic. All right, where's your booth exactly? Can you just like point?
There, behind there.
This pillar here, is it?
Yeah, the one behind. Yeah.
Great. I see the guy.
That's audio.
All right, so I don't know whether those here can see. There's some guy raising up his hand. If you are interested to see what Care 3 has in store for you, they are right there next to the pillar behind or next to
our booth.
The independent creative photography. Thank you, Care 3. Appreciate it. Pass it over there. Yeah. Okay. Now, this next team, before I introduce them, I wanted to ask them, how do you pronounce your team name? It is spelled MECIT. So just keep that in mind. I just feel like going down to the audience and asking you guys, how do you think MECIT is meant to be pronounced? Can I? How would you pronounce MECIT?
Mac it.
Make it. Okay, thank you. How about you, sir? How would you pronounce MECIT?
Misit.
MECIT. Okay, thank you. The two of you. So apparently a correct response or the way they wanted to share was MECIT is pronounced as make it. And when I asked them, is make it? Then they are like, yeah, because we can make it. So let's see whether they can make it. And let's put our hands together and welcome team Make It.
Hi, so good afternoon, everyone. My name is Alancha, and I'm here with my teammates today, Ishan, Yutan, and Hakim. Together, we are Team Make It from SIT, and let us share with you our prototype for people with muscular dystrophy. Prior to developing our prototype, it is important for us to do ample research on our end users and their needs to be met. Firstly, we found out that people with muscular dystrophy may have a slower blinking rate, which we can use to our benefit as an indicator to invoke actions. Next, we also had the opportunity to meet our community partners from MDAS, whereby they share with us their wants and needs from the prototype. They mentioned that they do not prefer to use voice recognition in public and also to be able to enjoy the process of photography with the personal mobile phones for convenient use. Our community partners also mentioned that they would prefer to control the application via eye detection. So this research and thought process let us create our prototype with a 100% hands-free solution. Our product consists of a motorized arm and a camera application that is controlled fully via eye tracking. The movement of the arm will be controlled and positioned based on face tracking by centering the user's face. This is designed to enable people with muscular dystrophy to have an easy, hands-free, and lastly, independent process. So now, let me take you through the steps of using our prototype. Firstly, the phone will be mounted onto the motorized arm, where you will track the user's face via app and assist to center frame accordingly. Next, user will navigate options in the mobile app via blinking of the eyes. User will then select their choice after 3 consecutive blinks, and lastly, photo is taken and saved into the gallery. So now, let us show you a video demonstration of our prototype for you to have a better understanding of it.
Unfortunately, the video is not in the slides, but if you want to watch our video or you want to see it in action, you can come down to our booth. So for now, I will talk about the future enhancement. So because our prototype is not that perfect yet, so in the future, we intend to introduce these 3 future enhancements to improve our prototype further. So firstly, we will add options that after the user have taken a photo, they will be able to share to their social media, because we understand that our community partners love to take photos and to share to their social media. So we are going to add a hands-free option for them to share to their social media. Next, we also want to add support the taking of landscape photos and the scenery photos, because currently our app only supports selfie. Lastly, our app is developed for Android, so we plan to introduce to iOS in the future so that we can cater to more users. Before I wrap up my presentation today, I would like to give a huge thank you to SIT for giving us the opportunity to participate in this competition, as well as Engineering Group for giving us the opportunity of organizing this competition so that we can take part in. Lastly, our community partner MDAS for providing us with this meaningful experience. Thank you so much, everybody. Hope you have a wonderful afternoon.
Thank you.
All right, thank you. If y'all think that they can make it, I no question, don't worry. Yeah, I cannot scold it already. I've done no more question. Okay, no more question. Yeah, lucky y'all. Yeah, no worries.
Thank you.
So if y'all think that they can make it, all right, head over to their booth over here on your left, if you're facing the stage, and do scan the QR code, as that is a voting system for us to decide which teams might get further benefits from this whole Tech for Good program moving forward. Right? Now, the next team coming forward is a team from Raffles Girls Secondary, and their team name is Picturesque Turtles. I don't know why, but it's kind of cute. So can you put our hands together for the team Picturesque Turtles?
Have you ever wondered how it is like to be unable to take photos on a daily basis? Well, persons with muscular dystrophy face this problem every day. So, good afternoon, everyone. We are Team Picturesque Turtles, a team consisting of me, Min Min, Tian Yu, and our mentor, Mr. Daniel Matana. So, our problem statement is independent creative photography. And our target user is persons with muscular dystrophy, which is a group of diseases that will cause progressive weakening of the muscles.
So from our interview with the community partner, we discovered that when users rely, We discovered that when the user relies on the caretaker to position the camera for them, it is often very difficult to communicate with the caregiver on the positioning of the camera. This results in an undesirable positioning of the camera and thus leading to unsatisfactory photos for the user. Therefore, our product focuses on allowing the user to independently position their camera so that users can take photos that they love. So to address this, we tinkered with a few models before settling on a final solution. We have tried the camera cap and camera goggles, which attaches the camera onto the user's head. However, upon interviewing with the user, we realized that these designs were not feasible as the weight resting on the user's body can be too heavy even for those with mild muscular dystrophy. Therefore, we decided to shift the weight from the user to the wheelchair. The initial design that we had was a 3-axis camera that moved along metal rods positioned in all 3 axes. However, this is bulky and blocks the view of the user. And therefore, we have our final solution.
Introducing EmpowerCam. So EmpowerCam is a controllable camera mount which empowers persons with muscular dystrophy to take charge of their photo-taking experience comfortably and conveniently. So we have 4 unique value propositions, which is variable camera angles, preview and review, mounted onto wheelchair, and customizable controls, which we'll elaborate more in the next few slides.
So firstly, we have variable camera angles. Our device makes use of a movement system known as the pan and tilt system, which is achieved through the use of 2 motors, allowing the camera to tilt left and right and move up and down. Our device is mounted onto the armrest of a wheelchair with a clamp. This weight rests on the wheelchair instead of on the person's body or the neck and shoulders, making it very comfortable for the user. So independent photography is achieved with our device through the use of a small device, which means less dependence on the caregiver. The entire process of photography can be done independently by the user with our device. So with that, Mimi will now demonstrate the device.
Okay, so hello everyone. I'll be demonstrating the device right now. So as you can see, this is our device, and this is, assume this is a wheelchair armrest. So we will be mounting our camera device onto the wheelchair armrest, and the user can then switch on the device. Okay, and the user can also position their, put their camera on this camera clamp right here. So to control the camera, the users can press like these 2 buttons on the micro bit. So if you press button A, you can see it's panning left and right. So the camera right here, it will face left and right. And as for the tilting, it will cause the camera mount to tilt up and down so that the camera can face the sky or face the ground. Yeah, so that's the end of the demonstration, and I'll pass it over to Terry to talk about our future work.
So in the future, we plan to make several improvements to our prototype. Firstly, we want to make the height adjustable. As you can see here, the height is right now fixed by the purple rod. So in the future, we want to make it controllable for the users, making it a pan, tilt, and height system. This gives the user a wider range of movement of the camera. Secondly, we want to make the phone holder tailored to all phone sizes. As you can see right now, this phone holder is made for a very specific size, a very small phone. So in the future, we want to make it with adjustable material such as a clamp or a flexible material so that it can fit phones of different users. Thirdly, we want to create an app that is integratable to all phone models, which allows more accessibility to users using different types of phones. The phone app will connect the user to different features on the phone, such as filters and lighting, as well as make clicking the shutter also controllable through buttons or voice control or eye tracking. This allows users with more severe muscular dystrophy to be able to control their phone camera independently as well.
Thank you. And if you enjoyed our presentation and you think our project has a potential to develop further, please do vote for our project by scanning the QR code at our booth, which is right in front of the stage right there. So thank you so much for your kind attention, and brought to you by Picturesque Turtles.
Thank you, Team Picturesque Turtles. All right, you guys can slowly swim away. Yeah, no question, don't worry. Okay, and next, last but not least, under the category of independent creative photography, we have a final team from the National University of Singapore. Let's put our hands together in a big round of applause for Team Krabby Patties.
Oh, really nervous. Okay. Good afternoon, everyone. I'm Yu-Quan. This is Shu Hui. This is Joanne. So today we are going to present our prototype on the problem statement. I'm not going to reiterate the problem statement because we are solving the same problem, but just different solutions. Yep, so I'm going to go through the background, the main features of our products, as well as some of the future improvements that we're going to make for our product. So when it comes to designing our product, right, what we do is that we have these three main considerations. First, it must be easy to use. Reason being is that for MD patients, they do not have much physical strength, most of them. And as much as possible, we want to reduce the amount of setting up, as well as even if they have to set up, some of the MD patients are able to do it on their own. Next, it must be affordable, because the more affordable it is, the cheaper it is, the more people can benefit from our product. And lastly, it must be versatile, because when it comes to photograph taking, it's a form of self-expression. It's a form of art. It's a form of taking your memories, keeping your memories. So if it's not versatile, whereby you only can take this kind of photo, then it is not something enjoyable for many. With that in mind, let me review my product, or our product. So we call this photograph taker. It's very boring, I know, but basically it's a phone holder that we attach it to the armrest of the wheelchair. The reason being we chose a wheelchair is because most MD patients are wheelchair bounded, so we might as well capitalize on that. So there are three main features in our product. So the first part is the robotics arm. So there's actually a magnetic mount, whereby I can actually mount my phone over here, so that you can control and take pictures of it. The reason why we choose magnet is because we want it to be easy to remove and attach. Right. Next is able to control some, to move in 3 axes. So it's able to turn 360, it's able to tilt up and down, as well as turning from portrait to landscape. All right. Next is our control. If you realize our control is very simple, reason being we want it to be easy to use, as mentioned before. So I just demonstrate once, probably all of you will be able to use it. So that's the whole point. If it's very difficult to use, I think you mentioned in one of the panelists, if it's very hard to use, it's very high-tech, right? Then there's no point, because some of them might struggle to use it, and then as a result, they might not even use our product. But by keeping it simple, more people are more willing to try it, and then from there they can diverge to other products. Last but not least is a clamming system. So this clamming system is a very simple design. We use a Velcro, and then we clamp it down, or rather attach it to the wheelchair armrest. We kind of design it to be universal, because we understand that a lot of them actually customize their wheelchair. So that means that they have different dimensions, different specifications. We will say that this is not a perfect design. Definitely we can improve on, and hopefully we can do that. And that brings me to other future improvements. There are a lot of improvements. In fact, this morning, there are a lot of people who give us great suggestions, and there are things that we never think of it ourselves. So I'm very grateful for that. But for us, the two main things that we want to do right now is, one, we want to centralize the power source. So right now, you may not see, it seems like I'm powering with one power bank, right? But inside there are a few batteries to power the servos. So eventually what we want to do is, we can just power it with one power bank or with one battery. Next, we want to integrate some smart features. Because right now, we don't have a screen. So for example, when it tilts at a certain angle, the user might have a difficulty to see what they are taking pictures of. So what we want is to have a screen mirror, a screen casting, and then a small screen. And from there, they can see what they are taking. Another thing we want to integrate is creating an app to track objects. So imagine they want to take a video of a cat moving around. You know, you have a pet cat, right? So rather than they having to move the joystick all the time, they can just tap on the cat to focus on, and then this will automatically track it. So this is something we definitely want to explore on if we are given the opportunity. So please do vote for us if you want to explore this, okay? Okay, so I'm going to end off with some of the insights that we get from this whole experience. So I joined as an individual, they joined as a team. We are from different schools. So it's a very meaningful experience to work together and use whatever we learn from school, because all of us are from engineering, to apply to a real life context. Like in real life, there's a lot of things that we don't consider, and that's something school don't do. And one thing about putting ourselves in the shoes of a target user, right, is that I realize that a lot of things we take for granted. Like when we take pictures, a lot of time when we see good food, we take pictures, we share to Instagram, we share with others. But for people with MD, they are not able to do that. When they are very dependent on others in some of the activities. And hopefully through our product or other people's product, they are able to do what everyone is able to do. So with that, I want to end off with one question to all of you who are actually listening. What is something that you think you have taken granted for? A very simple task. Like in this case, it's taking photos. But are there any other tasks that we actually take for granted? With that, thank you.
Oh, thank you, Team Krabby Patties. Wow, your ending question a bit loaded, huh? But good question. You helped me ask. Thank you. Appreciate it. And that was the last team under the category of independent creative photography.